So I will introduce myself because I'm not as fancy as Jonathan, so I don't get the raving introductions. My name is John Studarus. I'm a freelance security and compliance expert. I mainly work in finance, pharmaceuticals. So today we're going to spend some time and talk about pitfalls in security and compliance. So, what are the rules in compliance? If you're building out a cloud, if you're running some sort of SaaS service, what compliance requirements you're going to fall under. And then we're going to do some real-world walkthroughs. We're going to take a look at some case studies of real examples where companies failed, had issues with compliance, issues with security issues. And then we're going to take a look at how those items could have been addressed with various OpenStack components and technologies. And then we're going to wrap it all up with some recommendations for people that are doing OpenStack, recommendations on how to deploy it, how to configure it, what projects to use within. So a little bit back about me. I'm a software engineer by education, but about the last 15 years I spent doing software audits, risk assessments, and finance, pharma, some defense, healthcare. Okay, so compliance, what's out there? Does anyone work in compliance? You guys must have some interest if you're here today, but there's a lot of compliance out there. The first couple, PCI, payment card industry, if you're dealing with credit cards, credit card companies make you comply with that. They've got their own set of rules. Then the US have got a whole bunch. Individual states now, so Massachusetts, California, and the US have their own rules as well, so it gets even dicier if you're doing work in one of those states. EU's got a couple. They got another one that's coming out year after next that goes live. UK has got one based on the EU. Even China, they've got a couple. So Hong Kong. And then also maybe if you're working with customers, they might have their own security requirements. They might come to you and provide security requirements. They might audit you and make sure that you're in compliance with their needs. Now, all of these boil down into a set of controls: access control, authentication, user authentication, management of data, data transparency, moving data around from regions. Can I move this data from the US to Canada to the EU, back and forth? How has it been encrypted? How long can I keep this? Can I keep this after a customer leaves? All sorts of rules. So basically, I take this, I boil it down into whatever controls are applicable to the customer. So first example, this is a pharmaceutical company. They run a cloud solution where they roll out to healthcare providers, hospitals, whomever, a hardened physical box to dispense pharmaceuticals, mainly promotional, not trials, but samples. So if you go visit your doctor and you want to, trial some new drug, it'll be dispensed from this. And it's a cloud environment. So this box in the office communicates back across the cloud to a centralized location. Well, taking a look at this environment, turns out they've gone through and they've configured all of these boxes that have been shipped out for the last 10 years, all with the same default support username and password. So you run into issues then. Anyone who ever worked with the company, hey, they can get into this box, doesn't matter the location, and have access to it. They could make changes, change the quantities in there, change how much equipment, how much product is shipped out. So big concern there in a cloud environment. They also had an issue where their data center, I could watch people come into the data center. They would walk up, they couldn't remember the code, they would turn around, close the wooden door, and open the wooden door back up, and then go type in the punch code. So I took a look, went over, I closed the door, and back written into the grain of the door is the punch code to get into the physical data center. So most of us in this day and age, if you don't have to worry about physical security, you work in a cloud environment, it's somewhere else. But what it shows is the shared key. If you have shared keys in your cloud, in your application, whatever, employees, people who use the key tend not to have good security around it. They don't keep that shared key secure. So compliance requirements, where does this fall under? Basically, when you're deploying these things, you can't have shared accounts or passwords. Shared support accounts. Each person needs to have their own. In addition, since so much of the stuff is running across the internet now, Most places they institute for critical business applications. So if you're making fundamental changes, you're changing the settings in the system, you need to have some sort of form of two-factor authentication. Because nowadays people can log into these environments from wherever, you're down to your local Starbucks or coffee shop. Also need to have technology in there where if someone makes a change, you know it's that person that makes the change. You need to keep logging on. You need to trust the system to keep track of who's making changes. So what can we do in OpenStack to solve some of these things? Okay, so physical access control, we talked about that. When you set up your application, you need to base it on some sort of role-based access control, and Keystone is within OpenStack. If you're rolling your own role-based access control, I recommend you take a look at some, use Keystone, LDAP, something else, so you're not building your own technology for access control mechanisms. OpenStack recently, in Mitaka, Keystone now supports multi-factor authentication, so you can plug in Google Authenticator, you can plug in some other two-factor authentication mechanisms. It's not in Horizon yet, but there are some patches if you want to go through and put in multi-factor authentication in Horizon. But if you don't want to go through do that, I recommend, for compliance reasons, you have you VPN in before you give people access to the Horizon dashboard, VPN with some sort of multi-factor authentication before you give people access to the API. So that'll solve a lot of these access control rules, is add in some sort of two-factor authentication before people actually get access to the cloud management consoles. Customer segmentations, I see this quite a bit where, well, real-world example, we'll start off with that one. This is a data center provider. They provide data center space, and they actually run these environments for hospitals. Each hospital gets their own environment, but behind the scenes, they actually wire up all of those hospitals together. Each hospital has its own rack, but the admins have wired up a cable between each, so they can hop from hospital to hospital without having to loop back through. This sort of maps across into the virtual environment as well, because you can set up virtual circuits and connections across, basically bypassing firewalls. See this quite a bit. Admins add this in to make life easy so they don't have to re-authenticate when they go through between customer environments. Now, OpenStack has great segmentation. We're going to talk about segmentation quite a bit, where you need to segment each of your customers. If you have multiple customers, rather than putting them in one large environment, you segment each customer through. Unless there's a business need for the customers to actually talk to each other or have their data together, you really need to keep them separate. So in this case here, an employee who knew about these cables to connect back through, he left the company, he was fed up, he got fired. He came back and he actually used those connections to go through and connect back from each hospital and delete all the systems and take them offline. So he was found guilty and spent 5 years for that. So all because this little hack that the system admins had to make their life easier was used to defeat all the security in place. Segmentation at the application layer. See this quite a bit where rather than running a SaaS provider is running an environment, let's say they support pharmaceuticals, let's say they have 500 pharmaceutical customers. They put all 500 in the same stack. So they put them 500 customers in the same application servers, set of database servers, set of load balancers, set of firewalls, rather than segmenting them through. So what you end up happening is all of the logic to keep the customer segmented are in the application layer. So the application layer takes a look at who's the customer coming in. Oh, this is from pharmaceutical company A. Therefore, I'm going to put a filter in when they access the database records and only give customer access, or that person access to customer A's data. Unfortunately, we see issues where there's bug in the application logic. I mean, you talk to any application developer, he says his code's going to be perfect. But I was an application developer, I can tell you that no application code is ever perfect. There's going to be bugs in it. So we've seen issues where there have been bugs in the application layer, and customer A can see customer B's data. So the recommendation is when a SaaS provider is setting up, and if you're working with a SaaS provider, go through and ask, is my data going to be commingled in with other customers' data? Or am I going to get my own database instance? Am I going to get my own application servers instance? And in the cloud environment, this is very easy to do. you know, if you're using all the rollouts, the DevOps tools, Jenkins, you're doing builds, you should be able to go through and set up identical versions for each customer within the cloud environment, identical set of, so each customer gets their own set of application servers, their own set of database servers, and use the cloud tools to basically go through and roll these things out. Having all the data in a single database, you know, 500 customers' data in a single database, you run into issues with data removal. So a single customer leaves, their requirement is, and you'll see this in a lot of compliance, that their data needs to be removed from the cloud. It needs to be removed from the environment. If all 500 customers are in the same database instance, that means they're all in the same database files. That means their data is spread out and it's intermingled within other customers' data as well. So it becomes very difficult then to remove a single customer's data. You have to go through backup tapes going back forever. Basically, it's not a feat that can be done easily. So once again, the recommendation is each customer, if they do have a data removal compliance requirement, put them in their own database instance and keep their data segmented. So let's go on to the next. We talked about this. Segmentation solutions. So once again, we need to segment into logical partitions. We talked about this. When we talk about segmentation within OpenStack, that's the whole way down the stack. VMs, a set of individual VMs, set of separate virtual private clouds, networks, keys. It's very important for each customer to have their own set of keys. We'll talk about this in another example. You don't want to share keys across customers. Talked about this. Don't rely on application logic to provide segmentation. You're going to have bugs in the application. And OpenStack provides the tools to do the segmentation. Let's go ahead and use them. So let's move on to key management. So another real-world example. In the healthcare environments, there's regulations that require any marketing material, any material presentations have to be approved. They have to be controlled, just like you maintain your source code. They have to be maintained as well, so there's no unauthorized changes to the material that goes along with the product. So this is a company. They provide a solution where you upload their data, your medical data, your product data into their system. They keep track of the version control. They keep track of what versions have been approved, what changes have happened, and it's all in a cloud environment. In this example, happened to run on AWS. Unfortunately, doing an analysis of the system, all of the data for all the customers was all encrypted with the same S3 key. So for those of you familiar with Amazon, S3 is the data storage system behind it. It's the object store behind Amazon's cloud service. So what you end up having is you had all of the customers' data, customers that are competitors to each other, encrypted with the same data. Luckily, no one knew that they were all using the same keys, but obviously this is a fault in the system. So compliance requirements, what you need to do. You need to, once again, it comes down to customer segmentation. Customer segmentation, one way of doing it is proper key management. So you need to have separate keys for customer data. We'll talk about what you can do in OpenStack to do this. And keys are all across modern cloud environments. You got database keys, you got SSH keys. I bet you most people never change their SSH keys on their servers. They start them up and keep the same one going. SSL keys, S3 identity management keys. Key rotation, often you see that in a compliance requirement. That means keys need to be changed every 6 months, every year. This is keys, back-end keys that processes use. And then destroying data at contract termination. So a customer leaves, you need to be able to take data off of the cloud environment and delete it. So it's no longer there. In some instances, there is regulatory requirements that data needs to be maintained by the service provider, but that's few. So what can you do in OpenStack? So OpenStack does have a project that does key rotation. It's key rotation within Keystone only at this point. And then there are Barbican's come out. It provides key management. So it'll keep track of all the keys that you're using within the environment. At the application layer, you can use this to go maintain all the keys in the system. So it's a great way. You can keep track of all the keys across all your different customers. And Rackspace actually has an implementation of it they call Keep, where they go through and they'll actually run this as a service for you. So if you're using Rackspace's OpenStack environment, public cloud. And we're not quite there yet with encryption of data, but there are blueprints out there. Hopefully one day we're going to see some encryption built into it. Okay, capacity planning. In this example here, we had a sales incentive program. So salespeople, they sell product, they get points, they cash in the points, they can get prizes, you know, new TV or whatever. Cloud service, this company provided it across the pharmaceutical space. Big pharma signed up for the product. They told the customer, they told the cloud provider, okay, we're going to roll this out to 8,000 people. Monday morning, they emailed out to 8,000 of the salespeople. The salespeople get the email, they all click on it, and bingo, the service promptly crashes because they don't have adequate capacity. So what was the failure here? Load testing in the cloud environment. I think a lot of people don't do it because the assumption is, I don't need to do it, the cloud will scale up. But companies don't have the scale up turned on, or they don't know how much capacity does one of my instance support. You need to be able to understand that. If I use a small, medium, large, how much capacity will it use? If I'm running a private environment, how much additional physical hardware is this going to require? OpenStack does have some tools. They've got Octavia came out in Mitaka. HA proxy is available to do load balancing, but you'll still need to go through and have your own tools to go through and determine how much capacity am I going to need based upon my sales projections and customers onboarding. How much additional hardware am I going to need? How many additional virtual machines am I going to have to turn on? What am I going to need 6 months from now? Okay, subcontracting. So you see this a lot in the real world, where, especially in SaaS service businesses. So company A has a cool solution, but they don't actually develop the code. They turn to someone else. That other company goes and they writes the software. But company B, they write the software, but they're not an operations house. So they outsource it to somewhere, company C, to actually write this, to run the environment. So company C, well, they don't actually have hardware, so they go to company D, where they get the hardware from. Maybe it's a cloud environment, who then rents some server space, which rents some rack space. And the next thing you know, you end up with physical servers that are in some other country that company A doesn't even know about. Company F, that's all the way down, that's providing the hardware and the physical space, they don't know that company A is providing a compliance, a regulated solution that requires certain security. So I took a look at one of these and mapped it all the way down, ended up at a building where I walked in, no door into the data center, walked in their basement of this building, and there was the computers running, no physical access control in another country, and actually not even any firewall in front of their database server or anything like that. So the question is, who's at fault? You know, is it company F for not checking in with company A on, hey, what is this application that's running? Or is it company A, the company that's marketing the solution and selling it? So in the US, it'd be company A. They're the ones that have to validate that all of their subcontractors that they're getting services from, and that their subcontractors are checking their subcontractors and service providers all the way down the line that are validating that, yes, the data on the system is regulated, it falls under these compliance. You know, you need to, as a subcontractor, sign off and validate, yep, I realize that, and I will make sure there are adequate controls on that. So if you're all the way up at the height of the food chain, you need to do that checking. If you're further down, you're running a cloud or you're running some sort of application, don't be surprised if your customers come to you and say, hey, I'm putting compliance data on. I need to validate that you provide, you know, the adequate level of security, and that all your service providers, that you're checking your service providers underneath you to make sure that they're providing that. So location, make sure that where the data actually locates, because in these large public cloud environments, it's very easy to push of a button. You add in an additional availability zone, you add in some other public cloud environment, and your data is now replicated somewhere else. You need to stay up on top of where my data actually ends up. Change management. So in auditing, you often go, you take a look at an environment, you just pick a couple of records to validate that things are working fine. So this was an OpenStack environment I took a look at. And I was just going through the firewall rules. And I saw one of them was to 77, 77, 77, 77, which is sort of strange. And I figured, okay, is someone just lazy, just was doing a test and typed in 77? Or is this actually, a real rule in the system? So, looked up who is 77 and actually maps to that IP address range is owned by a company in Iran. So that's set off another red flag here. Okay. So we never were able to find out who made this change, why this change was put in. And the reasons were, within the company, there was lax change management. They don't keep track of who actually makes the changes. Within Horizon, within their system, they didn't have logging turned on to keep track of who was logging into it and who was making those changes. And there's no change control policy where changes that are made are approved by a second person before they're actually rolled out. So, so this rule ended up being deleted because no one could figure out, okay, why exactly do we need this? So what can you do within OpenStack to do this, to prevent things like this? So restrict access to your consoles and to your APIs. So once again, we talked about two-factor authentication, VPN access, have some additional layer in front of the OpenStack consoles that you're using to manage the environment. A lot of times people just have their Horizon console open out to the internet. Anyone that wants to go and connect into it can start guessing usernames and passwords and logging into it. If you haven't locked that down, I recommend logging that down with some sort of gateway management. Enable logging. So logging within the system, go through their tools that'll go and take a look at events going across the message bus within OpenStack, and we'll go through and correlate them and looking for suspicious activity. And then occasionally audit the firewall rules. Go through and take a dump of all the firewall rules and say, do we need these? Why do we have all of these rules here? And make sure that they really still are needed. Okay. Every once in a while, I'll see a company that builds their own. They've decided, hey, I'm not going to use an open source or enterprise software. I'm just going to write my own stuff from scratch. And oftentimes problems roll up where the person that wrote the software leaves, software development's done, that company or that person left, an operations team's running it. So this system here, it's a SaaS service provider, and one of the things I look at is show me that your event management, show me that your logging system will actually go through and keep track of failed logins. So in this, they had no record of anyone ever making a failed login in 8 years. They could show me no reports, no entries of anyone in the 8 years that the system was running. They got 100+ customers using this, each with a couple of dozen individuals using the system. So there's no record of anyone ever mistyping a password logging into this cloud service, which is really strange. And then there's also no documentation of any testing by the QA group testing that this component actually worked within the system. No QA group tested and made sure that, hey, if I type in a bad password, a bad username, that it actually logs it. So the end result is, you know what? You can't trust it. It hasn't been tested. There's no records of it actually ever working and catching anything. So you gotta wonder, has this ever worked? Or did something change to break it? But I put money on that it never worked at all. So compliance-wise, what you need to do. If you're writing your own software for basic functionality like this, it needs to be tested. You need to have documentation that says what it's going to do so a QA group can go through it and test it. If you make changes to it, it needs to be a regression test. The QA group needs to go through and validate that, yep, it's gone through and changed. Don't ever recommend writing your own encryption routines. There are lots of good standards out there to define all of the encryption routines out there. Anytime I see a company go through and write their own encryption routines, there's always a problem with it. So on the US side, NIST provides a list of recommended encryption routines. So in OpenStack, what can you do? So once again, I recommend not rolling your own stuff, using the projects within OpenStack. There are lots of companies that have tools that'll dive into the event logs, into the message buses and the events that are going across OpenStack. You can grab telemetry data out of OpenStack as well and look for suspicious activity, and there are tools that'll go through and do that for you. so you don't have to stay away from running it yourself. Okay, data retention. More than one SaaS provider I've talked to, when I ask them, hey, what do you do when a customer leaves? And they say, well, we keep the data. We keep their data just in case one day they ever come back. Because when they come back, we want to be able to, at a push of a button, turn the system back on, and bingo, their data's there. So that's a big red flag. When a customer leaves, the customer's data needs to go away. There's no real business case for the cloud provider to keep data on the system. So if you're using a cloud provider, ask them, hey, when I leave, is my data going to be removed? If you're providing a cloud service, make sure that you're not keeping customer data longer than you should. And I just recommend that you say, hey, contract termination plus some defined number of days, all the data will be removed from the system and customers can know, okay. And then give them tools to extract data out. So give the customer tools to get data out of the system, and then when they come back, give them tools that they can put the data back into the system. So you don't have to worry about, so you make it easy for them to come back if they want to. And in cloud environments, that's what customers do. They'll use your cloud environment one day, next day they'll go use someone else's, next day they'll come back and they'll come back to you. So you see that a lot going back and forth. But the real compliance issue here is there's no business need to keep data on the system. Okay, so just to summarize, on the OpenStack side, things that you should make sure you have in place. So Keystone, you can use Keystone at the application layer to manage all of your accounts. Definitely use role-based access control. Take all your users, define roles with it, have them set up within Keystone. Restrict access to the management consoles. You don't need to have those open to the world. You don't need to have the vast majority of them open out to even your entire company. You can just have it to the development team. You can have it to the system admin team. Event monitoring, use tools to tap into the events that are generated within OpenStack, looking for suspicious activity, things that are out of the normal. Capacity planning, have an idea of the workloads that you're running, how they run, how much capacity they require, what your projections are moving forward. There are even outside parties that'll tap in and track this for you. Encryption and key management, so key rotation. So, ways of encrypting data, make sure your data is encrypted as it's moving back and forth in and out of the cloud. It's important. And then using the key management tools that OpenStack provides. Customer segmentation, we've talked about this quite a bit. I recommend as far down the stack as possible. So rather than segmenting customer at an application layer and putting all of your customers in that same application, have multiple instances of the application. So segment the customer so that if there is a breach in one environment, that only the data in that environment is breached. So only that single customer's data, and you don't have to send out notifications to all the other customers' environments that there was a breach in data. And it also prevents, if a hacker does get into the system, from being able to move sideways into other customers as well, because you've got them completely siloed in their own virtual machines with their own key sets, in their own separate subnets, virtual subnets. Last, data exploration. So customer goes away, you remove their data, you tear down the entire network, and you delete their data, so you don't have to worry about maintaining that afterwards. So, any questions? Yes?
More of an addition to what you've said, was a great talk, by the way. Henry Nash, I'm a Keystone core contributor. Two things on Keystone to add to this. One is audit events. You can get Keystone, in fact, nearly most of the push now to issue CADF formatted audit events. So you can plug those into, a security event management monitoring system, for instance. So that's a good way of tracking that. Secondly, for Newton, we're trying to make Keystone PCI compliant.
Okay.
For data stored in Keystone. Hope we'll get there. We're nearly there. Which, although, I partially recommend what you were saying about, I don't, use federated access or something like that. It's far more safer than really putting your passwords inside Keystone. But if you want to do that, then you should be able to make Keystone PCI compliant with the Newton project.
Are there a lot of companies that are running PCI environments on top of OpenStack?
From a key perspective, we've, for many reasons, tried to push back and say, you really sure you don't want to just use LDAP or AD or federated, but there are companies who really want just use the SQL databases inside keys and yet make them PCI compliant.
Mm-hmm.
We've given up fighting and decided to do it.
Right.
But,
Right. Okay. Anything else? Yes.
Just a quick one. With data, is there a requirement that the user has to actually delete the data? Is there some kind of...
So the user, okay, so if I'm using a cloud service, I'm using some sort of public OpenStack cloud, am I responsible for deleting the data? Yes, because I'm the custodian of the data. So I need to have best practices on removing the data on it. But as a user, I don't know everything that the cloud provider is doing. I don't know, are they doing backups? Are they doing replications to somewhere else? Are they doing snapshots of volumes that I don't know about? So yes, as a user, I need to be the custodian of that data and delete it. But still, you don't have access to every nook and cranny that the data might end up, and that's why you need to lean on the cloud provider and make sure they delete it. So, and then also the cloud providers, whoever they're using underneath, make sure that they check that their partners are going through and deleting data.
There's no regulation, I think, anywhere in the world that says you're using some storage, for example, the company you're using needs you to delete the data before they can close your account or anything like that.
Before they can close your account, I'm not familiar with.
Yeah, we've had an experience, that's all. Jungle Disk
Eh.
was someone we used, and we terminated the account, and they were still billing, but they were saying that we had to delete all of the data ourselves because they weren't allowed to delete the data.
So I don't think that's a compliance requirement. That's probably their internal policies and saying, hey, we don't want to delete data because we don't want to be held responsible for deleting it. I'm guessing that's what.
That'd be their internal.
Yeah, I think. Yeah. So, but most contracts that I see with a cloud service provider say that you will remove the data when when our contract terminates for whatever reason, for cause or it expires, that within N amount of time, the service provider will delete the data out it. But most companies are good about, if they're putting it into their contract that requiring their service provider to delete it, they're pretty good about making sure it gets deleted from whatever access tools they have to go through and delete it. Yep. Yes? No, you.
There's also that compliance issue of making sure your data stays in the right region.
Right.
Which is going to get more complicated once the UK's got that.
Yes. Yeah. And I know on the Amazon side, it's like, the Middle East has requirements, but there's no presence in the Middle East. So where do you put it on the Amazon side? And they make it so easy at a push of a button to just replicate your data somewhere else. And in the large public clouds, you really don't know sometimes, is my data being replicated or not? But yeah, so EU requires it to stay. I don't know what the UK is going to do, if they're going to say, hey, yep, data needs to stay in the UK. But even the US and Canada, for banking in the US and Canada, US banks won't let their data go to Canada. And then there are companies that say, we don't want our data to come to the US because the US, government surveillance rules. So yeah, you definitely need to make sure it stays within the region. And also make sure your disaster recovery and your secondary site is within the same region, data governance region as well. So in areas like Hong Kong, what do you do there? Because you're going to be in 2 data centers in Hong Kong, doesn't do you much good. Yeah. Yes?
How do you handle the different encryption regulations? Because I believe India demand that you use, is it 125 encryption, and most of the Western world use 256, and if you're moving data, which a lot of companies do, from the West to India for development and back again, then
So that's interesting. I don't know about, I hadn't heard about that India requires a lesser encryption. I know in the States, the stronger encryptions can't be used overseas because the US considers it munitions and they don't want other countries to have access to high-class encryption. So I think it falls under sort of key rotation where you have to take data and you have to re-encrypt it with different key sets as it moves from region to region, it sounds like. I haven't encountered that with India, though. So how did you guys handle it? You had to, or you're trying to figure out what to do?
Customer told us there was a problem, and do they adhere to the local regulation, 256 encryption going out, or do they adhere to the 125 encryption, the landing end? And there is no answer, is there? You can't use both.
So is it a key length? Can you just use the stronger of the key length?
The government wants to be able to have access,
Yeah.
potential access to, and obviously they can
Right.
look at
Yeah.
the lower encryption rate rather than the higher encryption rate. So they have regulations to say that they like to lose the data if
Right. So, yeah, then I think it falls under a key rotation, and as you move data back and forth, you have to re-encrypt it. And unfortunately, it sounds like that would be the key there. Or some places require key escrow, where a key is set aside in case there's some sort of legal requirements or where the keys are available to get to the data that's encrypted, and those keys are given to the government for them to hold. So, yeah.
Stuff we do encrypted in HDFS, we do that for the end users to deal with that. We make it as strong as we can.
You make it as strong as you can, yeah.
And then sort it out.
Yeah. Yep. Yes, in the back.
If you're holding customer information on a cloud-based CRM system, do you have to does your customer need to be aware that you're holding that information on a cloud-based system as opposed to in-house or anything like that?
So when you say define what you mean by cloud, do you mean it's virtualized or that they've outsourced it?
Yeah, so we're not storing information on site. It's Salesforce, for instance.
Right.
If there's, I don't know, any kind of delicate customer information on there, do they need to be made aware that it's not storing it on site, it's actually off-site?
So in that, the customer is going to give you a set of requirements, and the customer is going to say, hey, this falls under this compliance here, here are security requirements. If you're using Salesforce as your back end, you need to sit down and say, okay, does Salesforce, that falls under you to validate that Salesforce has all the additional security requirements that you need. It's difficult for a customer to go and say, okay, I'm going to look at all of your technologies that you're using behind the scenes and figure out if they're adequate or not. I mean, larger companies may audit you and take a look, but most of them, they'll just say, here are the compliance requirements, please sign off that you've satisfied those and that you're checking for anyone that's using behind the scenes satisfies that. So, I mean, Salesforce in particular, I know in the pharma space and the medical space, there are some issues because Salesforce isn't a accredited system. So, healthcare data shouldn't be in Salesforce or Force.com or things like that. It is a multi-tenant environment, so there isn't segmentation, true segmentation. Everyone's in one large application space there. I see a lot of companies are reluctant to tell their customers their back-end technologies, but you should at least be able to tell them what security controls you do have in place, even if you don't want to go and tell them specifically, hey, I'm on top of AWS or I'm on top of Salesforce or something like that. But it really comes down to you, making sure that you're satisfying the customer's compliance and requirements.
I was going to follow up, so AWS3 does do encryption server-side, but it's going to be impossible to verify that's actually happening. If something's being paranoid, you basically have to use the client-side keys and give the key nodes.
Right. There's no problem at all with doing double and triple encryption, right? So if your cloud provider is saying, yeah, we're encrypting the disk, we're providing encrypted storage, fine, great, let them do that, you know. But you can encrypt the data and then give it to them and they'll encrypt it as well, right? So you can do multiple layers. And even at the database layer, if you have specific columns in your database that require encryption, you know, social security numbers, bank accounts, passwords, encrypt them in the database. And then if the file system encrypts as well, or the storage system encrypts as well, great. You know, it's encrypted there as well. That way, if you have to do a database extract, the required columns are encrypted, right? And if you have to move it across somewhere else, or if there's, you know, some sort of physical media, someone steals a hard drive, the whole data is encrypted on the hard drive. Yep. Any other security worries or compliance issues? Has anyone ever had a compliance issue? Yeah? Has anyone had to work with a compliance auditor? I'm going to apologize from all of us in advance there. Okay. Well, thank you.